All right, now we're doing the last 2 pages of the quiz review. This page gives us just a generic v of t for velocity. We don't have a specific equation. We're really just trying to work on setting up expressions that answer this. All right, we know that at time A, we're at a position of k, whatever that might be. All right, so 19 says, what's the average velocity from A to B? So 2 ways to do this. What I would do first is go 1 over b minus a. Let's see how much time is between there, and let's go 1 divided by that times the integral from a to b of velocity. So if you want the average value of something, you integrate that something, whatever that is, and you divide by the amount of time. That would work for us. Or another idea would be to do the position at b minus position at a over b minus a. Both of these are exactly the same. Both of them would work. What's the position at time B? Well, that would be the position at time A, which is k, plus the change in position from A to B, which is what the integral of velocity gives you. So k is where I'm at time A, and then if I integrate from A to B, it'll give me the change in that position. Total distance traveled is the integral from A to B of the absolute value of velocity. No need to add anything to it. This will just give you the distance you traveled. It doesn't matter what position you start at. That's not distance you traveled until, again, we're only worried about from A to B. The average acceleration from A to B. So now it's the change in velocity. So v of b minus v of a over b minus a. How did my velocity change? How much time did it take? That's my average acceleration, okay? Technically, you could go 1 over b minus a times the integral from a to b of acceleration. That would work too. How do you know if the particle is speeding up or slowing down at time b? Well, let's take v of b, the velocity at b seconds. Let's take a of b, the acceleration. Signs agree, speeding up. Signs disagree, slowing down. Okay. Write an equation for time t equals c where the particle's at a position of 0. So we start at a position of k plus, and that was at time A. Now we're going to time c. And what we're curious about is when will this position be 0? So it's the same idea as the one from above, just now we set it in an equation, set it equal to the position we want, and then we would try to solve that for C. Okay. All right, then we're given this table, and we're asked to use a trapezoid approximation to find the integral of the d of t from 2 to 12. And these were in terms of downloads per day, so we'll work on that in a second. So if I look at the first trapezoid, we're going from 3,000. So if I were to kind of work this out, there's 2 to 4. We're going 3,000 up to 3,500, right? 3,500. Put that up here, 3,000. Okay, so that one would be 3,000 plus 3,500 times the distance between them, which is 2 divided by 2. Okay, then for the next one, we're going out to 7, going up to 4,500 now. So that one would be 3,500 plus 4,500 times the distance between them, which is 3 divided by 2. Then we go out to 10 seconds, or day, I'm sorry, and that's up at 5,000. So now that would be 4,500 plus 5,000 times the distance between them, which is 3 divided by 2. And then last, we go to day 12, and that's at 4,000 again. So that would be 5,000 plus 4,000 times the distance between them, which is 2 divided by 2. All right, so then if I take a calculator real quick and kind of work this out, I end up with 41,750. And what does this represent? This is the number of downloads in those 12 days. And it really, we're saying it's approximate, right? We don't know exactly how many downloads there are, but using a trapezoid sum, we're approximating that about 41,750 times this was downloaded. All right, using our answer for number 25, would this approximate, what is the approximate average per day? Well, we think it was downloaded 41,750 times, and it took 10 days for that to happen, from 12 to 2. So we think the average rate was 4,175 downloads per day. And then 27 says approximate D prime 11. So at 11, if I come back to the table, we're looking for the derivative of D. So I want to know, how did it change? It went from 5,000 to 4,000. And that was from 10 to 12. So it went down 1,000 downloads per day in 2-day time. So on average, it was going down negative 500 downloads per day per day. So in other words, the rate, right here, the rate of downloads is decreasing at a rate of 500 downloads per day per day. All right. So this is a rate of the rate. That's what this is describing. Okay. The AP usually will give you a point for the value and then a point for the explanation. So there you go.